Alright, so in this video, we're going to go over investigation 5.3.2. So for the warm-up, hopefully we notice that this is an adding pattern. There might have been a typo right here. This should have said the 8th item. So notice that I start off with 2, and then it's adding plus 4 each time. So for example, if I add plus 4, you see I reach the 2nd item in my list. Then I do another plus 4, you see I reach number 10. So if I want to find the 8th term, and you keep adding, I'm at the 4th spot, 5th, 6th, 7th, 8th. So if I keep adding plus 4, plus 4, plus 4, eventually I reach the 8th spot, which is going to be 30. Similarly with the last one, instead of adding, this one's a multiplying pattern. Notice that I'm starting off with 1. That's the first thing on my list. And then I'm going to do times 5. You see I'm at the 2nd number on my list. Then times another 5, I'm at the 3rd item on my list. So if I want to find the 8th spot, I can just keep timesing by 5. I'm at the 4th spot, 5th spot, 6th, 7th, 8th. So we keep doing that 8 times, or for a total of 8 times. On the 8th spot, it should be 78,125. Okay. So in this lesson, we're going to be focusing on how to write an equation for a geometric sequence. So here we have a story. You can pause it and read the story itself. Basically saying there's a new Pi phone that's being sold. The pre-sale is going to be 100 phones, and we're expected to sell 15% more phones each week. So if we think of this as a total new percent, we're going to sell 100% of all the phones because those are pre-sales, and then I'm going to add an extra 15% each week. So 100% from before, plus an extra 15% we're selling each week. So that's going to change to a multiplier of 1.15. The way we figure that out is that 115 out of 100% means out of 100. That's going to end up being 1.15. Okay, so let's hide that. So how many Pi phones are sold after 4 weeks? So if I start off with 100 during pre-sale, again, I'm going to keep multiplying this multiplier. So if I do times 1.15, then I sold 115 in week 1, times another 1.15. During the second week, notice there are 2 of these. I sold 132 phones. For the third week, times another 1.15, it's at 152. And times another 1.15, it should be 174.9. So obviously I can't sell 0.9 of a cell phone. It has to be a whole number. So it should round up to 175. I think there was a typo or error on your program. It might show you an X right here, but the correct answer should be 175. There might have been an error on your side, but the correct answer is 175. Okay. So same thing with the Pi phone for 10 weeks. This time I need 10 of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9 weeks, and 10 weeks. And you might notice that this is pretty tedious, right? Just keep multiplying for each week. So a shortcut is, since I'm multiplying over and over again, I can represent repeated multiplication with an exponent. So this is the same thing as having an exponent of 10, right? Because I need 10 of these multiplied together. So imagine this is a 1.5, 1.5, 1.5, 10 times. This is just a shorthand for writing repeated multiplication. So again, like before, I have to round my answer. So this should be 405. Again, it might show an X for this answer, but again, 405 should be the correct answer. Again, there might be an error here, but that should be correct. All right, moving forward. So what kind of sequence is this? This is geometric because we're multiplying. Geometric means to multiply over and over. And if I want to find the 52nd term, I need to take what happened before. I take the 51st term and times that by 1.15. So if I take the previous number and multiply it by 1.15, I can get to the 52nd item. So take what we had before and multiply it by 1.15. All right, to show a recursive equation, a recursive equation needs 2 things. It needs a starting point and it needs a pattern. So for the starting point, I know I sold 100 during the pre-sale. So during pre-sale, during week 0, I sold 100. And the pattern is I'm going to take what I had before and multiply that by 1.15. So again, t sub n is the item right before, right? T sub n plus 1, that's the next term. This is saying the next term is equal to what happened before times 1.15. An explicit equation is a direct equation. So it works as when I plug in those numbers, it should give me the exact number of phones sold in that week. So the way we're going to show this is by using exponents. Again, we start off with 100 in pre-cell. We're going to keep multiplying 1.15 over and over again. And since we're repeatedly multiplying, we can show that with an exponent. We can have a variable for our exponent. So if I plug in 1, it will show me how much I have for 1 week. Right, if I plug in 1 right here, if I plug in 2, plug in 3. Okay. So depending on what I plug into the number, it should tell me what the equation or what the answer is going to be. So let's test it out right here. How many Pi phones should I sell during the 52nd week? So if I copy and paste, right? If I plug in 52 weeks into my direct equation, it says I should sell about this many phones, right? And like before, I need to round my answers. 1, 4, 3, 3, 1, 4. So again, I can't sell a decimal of a phone. So rounding it up to 4, right? During week 52, I can expect around these many phones being sold. Okay. Moving on to section B. So here we have a different type of phone, the iTalk. It's going to be a competitor to the Pi phone. They're selling 10,000 pre-orders, so that's before week 1. And then they're expected to increase by 7% each week. So I'm starting off with 10,000. Right, if I sell everything from before, plus I'm adding an extra 7%, that'll be 107%. But I need to change that to a decimal, so that'll round down to 1.07. So that's 100% plus an extra 7% each round, which is 1.07. Right? And since it's repeatedly multiplying, I can use an exponent to show that I'm multiplying by 1.07 over and over again. So that's going to be my equation. The recursive equation is going to be similar. Again, during week 0, I start at 10,000. And I'm going to take what I had before and keep multiplying by 1.07. So take what we had before and multiply by 1.07, and that'll give me the next term. All right, what if we sold 17% instead of 7%? So I'm just going to change this ratio right here. So let's copy and paste. So instead of selling 7%, I'm now going to sell 17%. So notice that this says 100% from before, and I'm adding an extra 17% on top. So 100% plus 17% on top is 1.17. Okay? And just like before, instead of multiplying by 1.07 here, let's copy and paste. If I'm increasing it to 17%, this should be 117%. Okay? So notice that my multiplier changes based on what my percentage is. So here's 7%, 0.07. Here's 17%, 0.17. Okay? So it turns out that instead of selling more each week, they're losing, or they're selling less each week. So I'm initially selling 10,000, but each week it actually decreases by 3%. So what's my new total percent? So if the original percent is worth 100, and I'm losing 3% each week, I'm going to subtract 3. So I'm only selling about 90% of what I had from before, right? 100%, and I'm losing and decreasing by 3%, so minus 3. So it's about 97%. That as a decimal, 97 out of 100, 97 divided by 100, that's going to be around 0.97. So that's going to be my multiplier. So how many phones did I sell during week 4? So if I start with 10,000, and then keep multiplying by 0.97, so week 1, week 2, week 3, week 4, keep multiplying, 1, 2, 3, 4. Looks like I sold around 8,850, round up to 53. Okay. And if I sold 10 of them, 1, 2, 3. All right, I'm going to keep multiplying it 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, 7,602. Wait, that's not right. Sorry, give me a second. 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoops, about more. There we go. 7374. There we go. Or shorthand, again, since I know there are 10 of these all in a row, I can write this using an exponent, 0.97 raised to the 10th power. Okay. Right? This means I have 0.97 written out 10 times. Repeated multiplication. So what's the direct equation? What's the explicit equation? Again, I'm starting off with 10,000 during pre-sale, my multiplier is 0.97. And since I'm repeatedly multiplying and using an exponent, n. Okay. The recursive equation, again, I'm starting off with 10,000. And I'm taking each step from before, so I'm taking the previous step, and I'm always multiplying it by 0.97. Right? T sub n times the previous term times 0.97. All right, moving on to section C. In a geometric sequence, the sequence generator is called, or the term that we're multiplying by is called the common ratio or the multiplier. So what's the multiplier from these other problems? So if I look back in section A, notice that I was multiplying by 1.15. That's called my multiplier. In section B1, if I look back, so for A1, you see it's 1.15 over and over again. In section B1, I'm multiplying by 1.07 over and over again. And in B2, I'm multiplying by 0.97 over and over. So those are my multipliers. Multiplying by 1.07, multiply by 0.97. All right, what do I need to multiply in order to get 8, 8, 8, 8, 8? So to keep it the same, I know that multiplying by 1 keeps things the same. 8 times 1 times 1 times 1 keeps it the same. If my term is less than 1 but bigger than 0, like 0.97, it's going to get smaller. Yeah, I'm not multiplying by 100%. I'm losing percentage. Notice that if it's less than 1, less than 100%, it's going to get smaller. And if it's greater than 100%, it's going to get bigger. The value is going to increase. All right, C2. Here we have two different tables. We're going to find the pattern and write the equation. So here, it's kind of difficult to figure out what we're multiplying by. Like, what times this equals 2,000? Again, we can guess, like 1,600 times 2. No, that's too big. Times 1.5. A little bit closer. So we can keep guessing. But shorthand is, I can always take the next term and divide by the previous term in order to get my ratio. So for example, I can take the next term, divide by what's right before it, and see that my pattern is times 1.25. If I check that with my calculator, start at 1,600 times 1.25, do you see I got the 2,000? Times 1.25, do you see I'm at 2,500? Times 1.25, do you see I'm at 3,125? So 1.25 is my multiplier. I'm multiplying by that over and over again. So just like before, I'm starting at 1,600. I keep multiplying by 1.25. And since I'm keep multiplying, that's going to be an exponent of n, right? Keep multiplying by this thing over and over again. All right, in table 2, same thing like before. I can pick two spots on the map, and I'm going to use those two consecutive ones to figure out my ratio. So I'm going to take the next term, so that's what happens next, divided by the one right before it, next divided by previous, next divided by previous, and I see that my ratio is 0.8. So if you notice, starting with that first number, if I multiply by 0.8 times 0.8, do you see I move down to here, times 0.8, I move down to here, times 0.8, I move down to here. So I'm multiplying by 0.8 over and over again. So my equation is going to look like I'm starting with that number, 3,906.25, and I'm multiplying by 0.8 over and over again, times 0.8 with an exponent, because I'm multiplying that over and over again. How are these tables related? Hopefully you notice that these are the same numbers. They are the same numbers, just backwards. And that makes sense because their slopes are opposites. You see this is 2,000 divided by 1,600. This is 1,600 divided by 2,000. Their multipliers are just reciprocals or flips, or just flips of each other. Right? So if I flip 1.25 over, it's going to become 0.8. And if I flip 0.8 over, it will be 1.25. These are reciprocals of each other. Okay. So moving on to the next example. Here we have two more tables, and same thing as before. Let's go and find my multiplier. Again, next divided by previous, next divided by previous. 72 divided by 50 is 1.44. So my equation is I'm starting with 50. I keep multiplying by 1.44 over and over again. Again, I can show you guys an example. So 50 times 1.44, do you see I'm at 72? Times 1.44, do you see I'm at 103 now? Times 1.44, do you see I'm at this spot? So I keep multiplying by 1.44 over and over again. That means I have an exponent. I'm repeatedly multiplying over and over again. All right, the table for this one. This one's a little bit trickier. Notice that it takes 2 jumps to get to 72. So it takes 1 jump times another jump in order to reach 72. So I'm thinking about what 2 numbers can I multiply that'll get me down to 72. Over here, I know it takes 1.44 to get from 50 to 72. So these 2 jumps has to equal 1.44, right? If I jump twice, right, it's the same thing as going from 50 to 72. So what 2 numbers times itself equals 1.44? I know that has to be 1.2 times 1.2. So I can show you an example. All right, let's clear this. 50 times 1.2. All right, I get to this row, and then times another 1.2. Do I get to 72? So if I jump twice, 1.2 and then 1.2, that's how I get to 72. Each jump is 1.2. Okay. So my equation is similar to before. I'm starting at 50. I'm multiplying by 1.2 over and over again. And since it's repeated multiplication, I can use an exponent. Okay. So how do we figure that out? It takes 2 multiplication jumps to get from 50 to 72. Right? And now we know that 1.2 times itself is 1.44. Right? So that must be 1.2, since 1.2 times itself equals a jump of 1.44. So since it takes 2 of these jumps, 1.2, 1.2, 1.2 times 1.2 is 1.44. So it takes 2 of these jumps to get to the same spot. Okay, moving to the next one. So here, you're going to read the situation. But here, basically, there's a deal. They save 20% off t-shirts, but they also have to spend a 5% tax. So after reading it, we're trying to make a prediction. Am I going to get charged more by adding the tax first? Am I going to be charged less by adding the tax first? Or does it matter adding the tax or adding the discount? Does it not matter? Does that not affect the price? So go ahead and pick one of these options and make a prediction. Do you think adding the tax first is going to affect the total cost? So go ahead and make your predictions here. After you made a prediction, let's go ahead and check it. All right, here's a new situation. Karen works for a department and receives a 20% discount. The store is also having a sale, which means they're also selling every item at a 30% discount. So basically, Karen has 2 discounts. She gets her employee discount of 20%, and the store is already having a normal 30% off. If she wants to buy a $100 dress, doesn't matter what order we discount. So if I discount 20% first and then 30%, is that going to affect it? Or if I do 30% first and then 20%, is that going to affect the price? So let's go and use these grids here to go and check the percentage. So let's say I discounted 20% off first. So I'm going to take away 20% off. Right? If this is a 10 by 10 square, 20% off is 2 of these rows. So I'm left with 80 squares. Okay. And now let's take away the 30% off from the store discount. So I'm going to take away 3 of these rows to show that 30% discount. So again, here in blue, I'm taking 20% off. And then 30% of what remains, 30% here. Looks like I have, let's see, 8 by 7. There should be 56 squares left. Okay. What if I did it the other way around? What if I gave you the 30 discount first? So let's get rid of the 30%. Right? I'm now at 70 tiles. And after the 30%, now let's take the 20% off. Let's do it the other way around. This time we'll take 20% off. All right, and if you count this up, this is a 7 by 8. 8 times 7 is 56. Right? So it doesn't really matter which way we do it. If I take the 20% first and then 30%, or 30% first and 20%, notice that I end up with the same number of squares. We end up with the same amount of money. So answering the first problem from Trixie, right? If I'm adding a 5% tax, 100% plus 5% is 105. But that as a decimal will be 1.05. Right, 1.05. Right, if I'm discounting 20%, again, I don't have to pay this 20%. So I'm going to take 100% minus 20%, which rounds down, or which changes to a decimal of 0.8. Okay. So if I multiply tax first, then discount, how much do I pay? So $50 for a shirt times tax times discount. I'm paying $42 for the shirt. But let's try the other way around. If I pay $50, give me my discount, give me my tax, I'm still paying $42. So it doesn't matter what order we multiply these in. Right? If I pay tax first and then discount, or discount first and then tax, it ends up being the same amount. So how do we write an equation for a geometric sequence? We need a starting point. Since we are repeatedly multiplying, we can use an exponent for the variable. Right? The variable is telling us how many times we're multiplying. Right? And since we're variable, and since we're multiplying over and over again, that's going to be represented with an exponent. All right, and finally, we have these practice problems here. So it's a 3% increase, so that's 100% plus 3%, which is 103. But that one as a decimal, 103 divided by 100, that would be 1.03. Okay. Here we have a 25% decrease, so we have 100% minus 25%. Oops. So I'm only paying 75, so that as a decimal would be 0.75. Okay. Here's a 13% decrease, so 100%. Plus 13%, I'm at 113. But if I reduce that to a decimal, it will be 1.13. Oh, sorry, decrease, sorry. 100% minus 13%, sorry, subtracting. So I'm decreasing by 13%. So that's going to be 87. So that would be 0.87%. And finally, a 2.08 increase, that's 100%, plus 2.08%. So that as a decimal, if I divide by 100, it would be 1.0208, right? 100% plus 208%. Okay. Over here, what kind of pattern is this? Since it's a straight line, this is arithmetic. Notice that we're subtracting 3 each time. So again, we're starting at 16, minus 3 we're at 13, minus 3 we're at 10, minus 3 we're at 7, 4, 1. So this is an arithmetic sequence. Here, let's see, 16, 9, 4, 1. Doesn't seem like a clear pattern. I'm not multiplying the same number. I'm not subtracting the same number. So this is neither. And here, let's see, I'm starting 16, then down to 8. Do you see how it's cut in half? And then down to 4, cut in half. 4 to 2, cut in half. So this is geometric. I'm multiplying by a half each time. Half, half, half here, half here. So each time I'm cutting it in half. All right, we're almost done. Part 3. So what equation is parallel to this? If you want a parallel line, right, it needs to have the same slope. So if this is negative 1/3, it needs to be exactly the same. Copy, paste. Right? And this time we're starting at negative 6. So our starting point is going to be at minus 6. So same slope because it's parallel. But this time I'm starting at negative 6. All right, let's go ahead and solve each of these. So if I plugged in negative 3 into here, so let's do 1 over x plus 2. If I plug negative 3 into my equation, negative 3, negative 3 plus 2, those are going to cancel out to give me negative 1. And 1 divided by negative 1 is negative 1. All right, so the answer is negative 1. All right, let's try the next one. Using the same equation, 1 over x plus 2. This time we're going to plug in 1.5 into the equation. So let's plug in negative 1.5. Oops, sorry. Negative 1.5. 2 cancel out with negative 1.5. That's going to be 0.5. And 1 divided by 0.5 is 2. So the answer to that is 2. All right, let's try the next one. This time I'm plugging in negative 2 into the equation. So instead of x, I'm going to replace that with negative 2. All right, negative 2 plus 2, those are going to cancel out, leaving me with 0. And can I divide by 0? Can I take a number and divide it by 0? Not really, right? So that's going to be undefined. And finally, for the last one, is asking, what number x should go inside so that the whole answer is 1.25? Okay. So I know that 1.25 is 1 over 4, right? That's 0.25. So what can go underneath that will make this 0.4? x should be what number? So when I plug it in, it has a 4 on the bottom. That means x has to be 2, right? If I plugged in 2, that gives us 1 over 4. So if x equals 2, if I plug in 2 to the equation, it tells me that the answer has to be 1 over 4. And finally, the last problem. What's the area of each of these figures? This is a square, so base times height, 7 times 7 is 49. This is also base times height, but since it's a triangle, we also need to cut it in half. Base times height, and then divide it in half. And here we have 3 sections. We have a triangle, a rectangle, and another triangle. So 6 times 6. 6 times 6 is 36 divided by 2. This has an area of 18. All right, 8 rows of 6. 8 times 6, that's going to be an extra 56. Is that right? Sorry, give me a second. 48, sorry. 48. All right, and 6 rows of 2. 6 times 2, that's going to be 12 cut in half, which is 6. So if I add up all of these sections, this one is 18, plus the rectangle in the middle is 48, plus the 6 triangle at the end, this has an area of 72. Okay, so those are all the problems. If you have any questions, you can always send me an email and let me know. All right, and thank you.